Okay, so happy to be here. Happy to see a few folks I recognize in the room. Yeah, so as Benjamin said, I'm a system architect for Sierra Wireless. My main focus is IoT cloud, device management, security. And I joined Sierra Wireless in 2011, so just here. And my background with that before was totally different. I was working more on classical enterprise software and a bit industrial automations. And as a M2M IoT newbie, I learned a lot because Sierra Wireless is in this business for maybe 20 years. So yes, I started the first embedded modules for connecting devices to cellular network 20 years ago. And yes, and mainly what we are doing at Sierra Wireless is connecting OEM, enterprise devices, object machines to the backend systems, or clouds, or premise, with a combination of hardware, connectivity offers, SIM cards, and cloud, and for more device management, data collection, and data processing. And there I worked a lot on some Eclipse IoT project, like Californium, Wakama. I started Leshan also, and used Pao and Mosquito a lot. And yes, and as a new IoT, as a IoT machine-to-machine newcomer, I learned a lot. And yes, when I joined, I think it was the beginning of the Eclipse M2M working group. And it was maybe next year, something like that. We changed the name from M2M to IoT or something like that. And sometimes it's difficult for me to understand what is the difference between machine-to-machine and Internet of Things. So I don't know for you if someone have a definition of what is machine-to-machine and Internet of Things as, of course, two different concepts, maybe. I spend a lot of time trying to figure out that. And yeah, for me, machine-to-machine is more connecting the device to a backend system, and this backend system have a kind of application for monitoring, configuring the device, and here, yes, the focus here is really connectivity and connect the device and manage the device remotely. And yes, and Internet of Things is a bit larger picture. Is a bit like you have a different connected application, like I don't know, a smart car, connected cars, smart lighting, air sensor. You know, in cities, air sensor for quality air, and you combine everything from making a smart city application. So it's a bit that, and. Yeah, and if you look at the Eclipse IoT reference architecture from the white paper, yes, it's IoT architecture white paper, I think, the name. What you see here is a lot of greasy details for building IoT application, from hardware, devices, cloud. Some project focus more on protocols, some on operation, on security, on connectivity. It's a lot of complexity. It's quite interesting to see how people approach this complexity in this business. And every year Eclipse is running this survey for targeting mainly developers, and it's interesting to see how it's evolving with people building a first prototype and then starting to deploy and deploying more and more and more, and we see a trend, I think. Like 5 years ago, when I was speaking with customer, security was a concern, but not so much. It just ask you, is your solution secure? Yes, it's secure. We put some security in, and they were happy. Since the first IoT security issues we got in the news, people started to be crazy about security, and now it's everybody a first question. It's funny because for me, if you look at the different problem you have here, Some are very complex, some are very difficult, and some maybe are not so well known as much as security. For example, for security, we have security experts and stuff like that. For other stuff here, it's a bit more difficult. If I try to do my main concern for connecting a device, I think the first one is really connectivity, which appear in as the third one. Is quite obvious. You are connecting devices and you have some connectivity in the middle. The first one, yes, is the reliability of the solution, because I think it's linked also for return on investments. If your solution needs to work very well, if you want to be able to build a business on top of that. If you have issues or availability problem, it's probably going to be a business problem on the long term. And yes, and the last one, security. Yes, for security, I have the feeling that it's not so difficult if you just take the time to look into the problem and try to assemble the well-known part, open source project, open source implementation of standards, and the good practices is like cybersecurity is something we start to know well for a long time now. It's a complex problem because you need to have all the details right. You need to do different things from, of course, device communication encryption, device authentication, signing the code you are deploying on the device. On the long run, if you deploy for 10 years or more, you want to be able to change some part of the system, like the algorithms, the keys. Yeah, and also to manage your device and maybe at some point to monitor the behavior of the device and the solution to detect some breach. Yeah, so yeah, connectivity. So why I think it's quite hard. It's because sometimes it's just kicking you in the face because the customer calls you and say, hey, it's not working like yesterday. I have some high error rate. Some commands are not working correctly. I have random execution failures. What's going on? And it could be a chain of details from the device to the backend system. You have a lot of different connections, different hardware, software, and also a third party in the middle. If, for example, if you are using a cellular network, maybe you are roaming, you are roaming on another network, so you have maybe two network operators in the middle. Yeah, it's an example, so it's a real life example. I'm not going to give the name, but one customer called us and said, hey, I don't understand. I have a lot of error failure at 3 a.m. in the morning. And so we were looking at the system, say, okay, it's strange. Why they are connecting so much in the morning? And basically, they synchronize all their devices using the cellular network, so they have a very good time synchronization. And they connect all their devices at 3 a.m. at the same moment for reporting the daily data. And so it's an effect on the network, so the network is overloaded, the cloud service is overloaded, and the device also was coded in a strange way. So you have a small timeout, and after the timeout, the device retry every second. So all the devices try to reconnect like crazy. It's not a very difficult problem to debug this one, but it's just to show that we don't have today. We start to have standard to explain how to connect a device to backend with backoff and randomization of the connection, but it's still not very clear how to do that, and we don't have today a clear standard. Maybe we have one in the GSMA, more focused on cellular devices, but for protocols and things like that, we don't have a very well written way to do that. Yeah, and yes, and connectivity, sometimes it's the connectivity, sometimes the network coverage, so the network coverage can change. It's funny, but one day you have a signal on the device, and the day after it's lost. So you need to have some kind of tools to know what is the history of network coverage of your device, so you can know that yesterday the signal was very weak. It was working, but very weak, and maybe it's that, so just the coverage broke. Power and heat also can have an impact on connectivity, and yes, and software failure can. I've seen some funny bugs where the device reboot due to a bug all the time and try to connect to the cloud and send hundred of messages all the time and saturating the system. So yeah, so maintaining device connectivity over time is a challenge. You need monitoring, you need tools for debugging that and for solving that. The other challenge I see here, and this one is giving me a bit nightmare, is it's breaking devices, connected devices. So sometimes, well, you need to do everything for avoiding that, but you don't want to be in this position where you need to call your customer and explain that, can you send me someone on the light pole or somewhere else to pick the device and look what is the problem, or send the device back to me because maybe we have a software issue, or maybe we have bricked the device with the last firmware update. Yeah, it's a challenge to avoid truck rolls, and it's something sometimes it's overlooked, the safety and reliability challenge of IoT. You are going to connect devices, sometimes it's very remote, like pipeline monitoring, smart cities. You have the skills, and sometimes you have the difficulty to access to the device, and you don't want to not being able to remotely troubleshoot it, and yeah, and you don't want to be in front of your customer and to explain him you need to send you back the device for whatever reason. This one is an interesting example of this kind of operational issue. So it's a smart lock manufacturer, and they send the wrong firmware update to some devices. So basically, they bricked 500 devices. So it's not huge, but it made a lot of noise. Basically, they got 2 series of the same hardware, and they sent the firmware 7 series to the series 6 model or something like that. So it breaks the device because the device was not able to boot the new firmware. So what also it's interesting is the perception of the user here. The user, so it's a comment on the article from Ars Technica, and the guy say, hey, this is a big deal. Basically, I'm locked outside of my house. It's not acceptable. But it's funny because it's an electronic device. It's a smart lock, and you could have any hardware failure here, like a power supply, well, the battery or electronics or whatever, and be locked outside. So I think we have a low threshold for software bugs and human mistakes, because I think if it was an hardware issue, it would probably make not so much noise. We are used to have a failing appliance like your dishwasher or whatever. They are having hardware failure all the time, and it's not a big deal. So yeah, if you want to, for example, to solve this problem of having a reliable firmware upgrade over the air, what I learned from my colleague doing machine-to-machine for a long time is you need to embrace the failure. It's going to happen. You are going to have failure. You are going to have power failure in middle of flashing. You are going to have network coverage failure in middle of downloading. You are going to have untested software compatibility. So it's one thing testing 1 or 2 devices in the lab, but sometimes when you are deploying at scale, you discover software issues and also operational problems like sending the wrong firmware to the wrong device. So a classical way to fix that is to do this kind of dual system upgrade architecture. So You have an active partition. You have some shared partition with some common configuration parameters and maybe the bootloader. And when you want to write the new system, you write it on the update partition, you patch it, and you boot the new one. So you declare the second one active and you boot that. And if there is a failure, you try to roll back. So you can, for example, the system is unable to boot, or maybe you are not able to start the application. The application doesn't like the new firmware or whatever. The application maybe are unstable, so issues in the application, they stop, restart. Or maybe your user is going to call you and say, hey, you have sent a new software update here. Well, it doesn't work. It's not working like yesterday, please roll back. So you can roll back remotely. You just need to switch the partition and reboot the system. And yes, and you need to be able to resume flashing in case of network loss, power loss, and it's a challenge, especially on power loss side. Yeah, so for fighting truck rolls and operation problem, you have a lot of things to do, a lot of monitoring tools to deploy, debugging capabilities to have. And yes, and also power management is coming back a lot with the new LPWA trends and people running devices on battery. Everybody say, yeah, it's going to be a 10-year lifetime battery with sending a message every day. But you need to monitor what the device is doing and how the battery is doing, because if there is any problem, it's going to drain the battery and kill the battery and kill the device. So yeah, so if I go back to this diagram, so what we can see, so machine-to-machine is still a big focus for Eclipse IoT and open source project in this space generally. Probably because it's still a difficult problem to solve. Yes, it's like if you look at something like MQTT, which is quite stable and widely used, we are still doing change on MQTT. So I think we are not still there. The connected device challenge is still not very easy to fix. It's still not like the web. The web is not a commodity. If you want to deploy a web server, even at scale, we have open source implementation, a lot of experience, a lot of web developers, a lot of recipes for doing that also. And sometimes people come to me and look at Eclipse IoT stack and ask, hey, I want to build my IoT app, but I see a lot of greasy details, a lot of projects I need to assemble, I need to do what I need to do. I just want to develop my IoT applications. I don't know if it's because it's our machine-to-machine grassroots, or it's maybe because people are overlooking the challenge in the IoT buzz. But yeah, or maybe people are used to use the web in a very convenient way and expect the IoT should be the same today. So what I see, it's still a very new domain and a lot of opportunity in this connect device to server problem. A lot of space for continuing to grow open source project and to discuss best practices and yes, then to develop the game-changing IoT applications. And yeah, and we will see today with the different projects like Ogbit, which is a typical interesting machine-to-machine device problem where you want to upgrade a device, or the next speaker, which is speaking about high-level IoT application for changing people's life. Thank you.